like writing papers, but at that time Dimitri was looking for real problems. Like he really wanted to work in industry, so like he was learning like new technologies, like Go programming languages, which he will introduce today. And based on that, he actually got like a very nice offer position in California, like for one of the startups, like Trigit. Then he actually went into another startup, like
SourceGraph.
SourceGraph, doing a lot of like open source development, contributor, which now in transition he's doing. So basically, he will tell the story like of his recent path career. And I really like the title, especially the second part, like how to do what you want and get away with it. Right?
Sometimes you can.
So basically, yeah. So I'll pass now to you, Dimitri, and thank you for coming. We're really very excited.
Great. Thank you, Jarek. It's good to be here. So, as you said, my name is Dimitri, and I've been involved in the field of software development for the last decade or so. And started out by, well, it didn't start out, but I did finish my master's at York University. Then I worked on an experimental project for about a year. Then I went to California and worked and lived in San Francisco, worked at startups there. And then I came back. So last year I was here, and I was spending that time working on open source, working on my personal projects, and really kind of doing whatever I wanted. So I'm going to tell you a little bit about my journey and how that happened. And I want to kind of share some of the highlights, some of the things that I've seen, show you some of the cool projects that I've worked on. And also, I want to tell you about my favorite language right now, the programming language that I use most often. It is Go. And I'll give you an introduction to that. So this talk will actually be two parts. The first, it's an introduction to Go, and the second is about my journey. Let's get started, but first I want to ask you, which programming languages do you know? Which ones do you use? Yeah, just shout them out. C++. Nice. Awesome. Okay. That's a lot of variety. That's excellent to hear. What about, which ones do you really, really like? Like, show me excitement. Which ones? Nice. Okay, awesome. What about on the front end? So like just things that run inside the browser. What about JavaScript? Yeah. Not a lot of choice there. All right, that's good. So as a preface to what I'm going to say next, I want to make sure that you know that it's really great to try as many languages as you can. Have an open mind, and it sounds like you already are well underway. And don't be afraid to use what you like. If there's something you prefer, it's completely fine to use more of that. And the programming language Go, it's a little bit unique, but I think giving it can give you somewhat of an edge. So that's why I want to share it with you. So you may have already heard of it. It's a programming language made by Google. They open sourced it and released it for the world to use. This is its website. That's what it looks like. So it's described as a programming language that makes it easy to build simple, reliable, and efficient software. And that is the Gopher, its mascot. So it is definitely my favorite language right now, but I think you might like it as well. So what is it? It is a project that kind of is comprised of its language specification. There's a small runtime. There are 2 compilers, and if I have some extra time at the end, I might actually mention a third one. A batteries included standard library. So I really want to emphasize this, but the standard library in Go is just incredible. So here's a list of the packages, and these are all included in a standard library. So if you ever want to deal with maybe archives, zip or tar, or you want to compress some FLAY, gzip, zlib, or maybe work some crypto things with DSA, DSCipher, maybe some encoding. Are you a fan of base64 or 32 or CSV, JSON, etc.? If you want to parse Go, there's a package to do that in the standard library right here. If you want to do some hashing, if you want to do some work with images, say parse a PNG or a JPEG, etc., etc. There's the net package, and we keep going. So these are all in the standard library, and they're all very easy to use, and they have a lot of powerful functionality behind them. And there's even more in the sub-repositories here, and even more that people have created. Go also comes with really excellent tools, tools for everything that is involved in software development, and they take that documentation very seriously, so it is really easy to read. Now, if you were to ask me what is Go about, I would say that one of those things is composition. Go, it is object-oriented, but not in the usual way. So there are no classes, but you can attach a method to any type. There's no traditional subtype inheritance, so no hierarchies of classes, but the interfaces are also satisfied implicitly, so you don't have to say this type implements that interface. If it has the right methods of that interface, it will just satisfy it and implement it. And as a result of these things, you have simple pieces that are connected by small interfaces. And I think this leads for some good design. Another thing that goes about is concurrency. It provides these concurrency primitives that make working with concurrency a much better experience. So it comes with these lightweight threads. They're called Go routines. And there are also channels, which are typed thread-safe communication and synchronization primitives. And with these, you have comprehensible concurrent code. So you've probably known that writing code is hard. Reading it is sometimes hard, especially if somebody else wrote it. But reading somebody else's concurrent codes, that is the hardest. Now, Go tries to make that process as easy as it can be. Now, lastly, yep.
What is concurrent code?
Concurrent code means things that can happen at the same time, concurrently. So parallel and so on. Multi-threading, that's right. Go is also about gophers. They come in multiple sizes, shapes, and forms, but they're all cute like that, and they're important to the language, so keep that in mind. These are the three core values, you could say: composition, concurrency, and gophers. So let's get into a simple Go program. This is a hello Go program. It starts with a package clause at the top. It says it's a main package. That's going to give us a binary that we can run. It will import fumpt. That is a package in a standard library for formatting text. And then we're going to call fumpt println hello Go, and that's going to be inside the main function, which is the function that gets executed first. So this presentation software lets me execute Go codes for convenience right here, so I can do that, and you can see that the output is hello Go. Let's move on to a slightly more interesting example. So this is hello net. It starts off, so this program will basically open up a TCP socket, and it will start listening for connections. And when a connection comes in on that socket, it's going to print hello to it, and then it's going to shut that connection down. So the way it works is we import the net package because we're going to be using the network. We define the listen address to be localhost 4000, port 4000. That's a constant here. We'll call net listen with that address. So that will open up a socket of TCP type, and it's going to start listening, and L is going to be the net listener. If there is some sort of error that has happened, we're going to call log fatal, so basically bail out and print out that error to the standard error. And now we're going to do this for loop, which is basically loop forever, kind of like a while loop. And inside of it, we're going to call the accept methods and get a C, which is a net con. It's a connection. Again, if there's a problem, we bail out, and then we're going to print hello to C, and then finally close that connection. So if I run this program now, I'm going to go here, and I'm going to use netcat. It's a simple program that just connects to a socket and prints out the output. So we're going to connect to localhost 4000. We're going to see that it prints out hello. So we can do that multiple times. Okay, let's make this a little bit more interesting. But first, let me show you something that happened on the previous slide. We used fumpt println to print hello to C, but C is a TCP socket. So how did that work? Well, it was thanks to interfaces. Because the fprintln function is defined to take the first parameter that is IO writer, and writer is an interface that is defined in the IO package and has this one method, write. It takes a P, a slice of bytes, which is basically an array of bytes, and then it returns how many bytes that is written and an error, if any. But C, the connection that we have, is an interface that has these three methods. So one of those is the write method of the writer, and therefore we can use C and pass it to fumpt. So fumpt, the package that has to do with printing text, can now print to a TCP socket, even though it knows nothing about networking, but it does know about I/O. And interfaces allow these components to work together. So let's step it up a bit and make this an echo server. So now, instead of just printing hello once, the server will echo back whatever you say to it back to you. We'll do that by replacing the bottom portion of the program here. We're going to use IO copy, and this will copy everything that comes into C back towards C, the connection. So I'll run this. So now when I connect to localhost 4000, we can see that it echoes back everything I've said. But can anyone see a potential problem or limitation with this program? Is there anything? So we'll get here. We'll start copying from C to C. Any issues? So this will start copying, and we'll keep doing so until that connection goes away. So the problem is that if I try to connect from a different place, and I start typing stuff here, well, nothing happens here until I close the original program, and then it works okay. So the program, it's not concurrent. It's only able to handle one connection at a time. Let's try to fix that. We'll use Go routines. So Go routines are Go's lightweight threads, and they're managed by the Go runtime. So they're easy to use. In order to spawn a Go routine, all you have to do is prefix a function call with the keyword Go. And then that function call will be executed in a separate, the body of that function will be executed in a separate Go routine. So in this example here, we'll have the say function. It takes a string of text and an integer. And what it does is it sleeps for that many seconds and then prints the text. So here are the three invocations of say. And the first one will print that string after 3 seconds, that string after 2 seconds, and this one after 1. And we'll just sleep for 4 seconds at the end to make sure that we see all of that happen. So when I run that, we see that it works as expected. So to make that previous echo server concurrent, we literally have to type 3 characters, G, O, and space. So now that IO copy will spawn in a separate Go routine, and the for loop can keep on looping and accepting more connections. So if I run this, so you can see that it handles both connections at the same time just fine. All right, so this has been a very simple example. Let's try to make something a little bit more interesting. So for those of you, we're going to build something that is like chat roulette, but for those of you who are familiar with it, you'll be very pleased to hear this is a text-only chat roulette, so nothing to worry about. So this program, it's roughly going to work like this. It's going to accept connections, and when a user connects, he's going to wait a little bit, and then a second user connects. This program will match up these 2 users, and then everything that one user sends or types will be sent to the other user, and everything that the second user types will go to the first. So that is the general design. So I already described the general design, but I'll just mention that copying that data, that's relatively easy. The hard part, just like in real life, it's finding a partner for one of the connections. So here's a little design diagram. This on the left is the echo server. It works as before we've seen. Every connection that comes in spawns a new Go routine. So here's a red connection, and this is a Go routine that's running IO copy. And it just keeps on doing its own thing. And here's a second connection. It's also going to do IO copy. Now the chat server, on the other hand, it's going to be a little different, and the difference is that now when the connection comes in, it will go to match, and the first match will just wait, but when the second connection comes in, the match will actually talk to the other match function. They'll have a brief conversation and decide that one of them will pass its connection to the other match function. And now that this match will have 2 connections, it can just start a chat And the chat will do something similar to before. It's going to spawn to go routines. One will copy from user 1 A to B, and then the other one from B to A. So channels are something that we'll have to use here to have those match functions communicate. And go routines can then use them to kind of synchronize and or send data to each other. So a channel is something like a Unix pipe. It's this typed conduit, and you can send or receive from it. They can be either synchronous or asynchronous. So when they're synchronous, what that means is whenever you're sending something across the channel, there has to be somebody on the other side ready to receive, and when they're ready, that communication will happen. But if there's nobody ready on the other side, it will just block. So here is a simple program that demonstrates this. The fibs function takes ch, which is a channel of integers. That's the syntax for declaring channels. And what it'll do is ch here will get the values of j, which are Fibonacci numbers. They'll be sent to ch. And in the main, we're going to say ch is a new channel of integers. We're going to spawn this go routine fib ch, and we're going to loop 20 times, and we're going to try to print ln, and here we're going to receive from the channel. So the fibs function will produce these Fibonacci numbers, and if you look at the arrow, you can think of it as the arrow indicates the direction of the data flow. So the j value is being sent into the channel, and here we're receiving from the channel ch, so the value comes out of it, and we're printing that. So when I run this program will print those Fibonacci numbers. Now, channels, they're useful on their own, but they're made even more powerful in general with the select statement. The select statement, it's somewhat like a switch, but what it selects over are channel operations. And the important part is that it picks exactly one of the cases. So here's another program. We're going to use some helpers from the time package here. The new ticker here, it's going to give us a channel that produces a value every 250 milliseconds on that channel ticker. Time after 1 second, that's going to give us a channel that will have a value on it after exactly 1 second. So we're going to loop, and here we're going to select over these two cases. The one case is we can receive from ticker, and if we do, we'll print tick. The other case is we receive from boom, which should happen after 1 second. We'll print boom and return. So when I run this, you get what you might expect. Yep, it works. All right, so now we're going to modify that original Echo server to create this chat program. In the except loop, what we have to do is replace that original IO copy and instead call match. So we're going to pass the C, which is the TCP connection that we have. So I'm going to talk about match right now. That's the function I kind of glossed over. How does it do its job? So the way it works is the match function accepts this IO read write closer. And this is also an interface. It is kind of a subset of the network interface because we don't really need everything that the TCP connection offers. We only really care about the ability to read, write, and close it. So we're going to make it a little bit more narrow. We're going to print, hey, waiting for a partner here. And then we're going to select one of these two cases. So the one case is that, oh, and there's also this partner variable. So that is going to be a global. There is only one of these in the program. And is a channel of these IO read write closers. So the two cases are, we'll either receive, we'll either pass C, which is our TCP connection, into the partner channel. And if we do that, then it's going to be handled by the other go routine, so we do nothing more. Or the other case is that here we're going to receive from partner, and that's going to be a new partner, P. And if we get that, then we have two partners, and we can start chat between them. So the way to think about this is when the first match happens, there's a TCP connection, it's going to block because neither of those two cases can proceed. There's nobody that's going to send a value on partner, and you can't send on that channel either because nobody's ready to receive. But when the second partner or connection comes in, there will be two go routines running. Both of them are running this match function, the same function, but one of them potentially will have this case occur. C will get sent to partner, and the other go routine will have this case happen. It will receive that partner, or maybe this go routine will send it, and the other one will receive it. So in both those cases, it works out just fine. And the chat function itself becomes quite trivial. It will just take the two connections, and it'll print to both of them that it found a partner, say hi, and then start the copy process. So let's do a demo of that. So I've started the first connection, and it's waiting for a partner. Now I'm going to start a second one, and there we go. It found a partner for both of them. So it worked, but there's a bit of a problem. So we saw that the first partner, it kind of had the conversation briefly, and then it went away, but the second partner was never notified. So he just kept chatting forever away into that void. And I think we've all been there as well. So let's fix this problem. So how are we going to fix it? The problem is that we didn't do our jobs. We didn't handle the errors properly. And this is why it's very important to clean up and to handle errors. So when the conversation was over, we didn't really pay attention to the error that was returned. So what we'll do now is we'll modify the chat function slightly, and we're going to pay attention to the error. So the IO function that we were, IO copy function that we were using previously, it actually returns the error. And this will typically be the closet, the socket has been closed, or there's been some sort of problem. So basically it lets us know that the connection is gone. So we're going to create this little CP helper that is going to capture that error value and then send it over this error C channel. And this little arrow here just means that this is a send only channel, so we can only send to it in this function. But back in chat, we'll do everything as before, print found one, and we'll create this error C channel. It's a channel of errors. We're going to create spawn these two CP go routines, passing that channel, and then we're going to receive from error C. So we're going to wait and block until one of those, either of those two copy function fails with an error, and then we're going to print it so that we can see what it is and close the two connections. So let's do a demo of that. So I'm going to connect in the first terminal here, connect the second one. All right, so when I quit in the first, you saw that it also quit in the second. Pretty cool, huh? Are you impressed? Okay, I know what you're thinking, right? Who wants to be talking over raw TCP sockets? Like, what is this, 1995? So let's make this a little bit more modern and make this into a real web app, right? So I actually want to show you just one more quick thing here before I do that, before I get into that, and that is a much higher level program. So this was obviously very low level. We were dealing with raw TCP sockets, but suppose you want to use Go to spawn a web server. This is a web server that fits on a single page. So we're going to import the net HTTP package this time, and this is the HTTP server. We're going to handle the route slash. The slash just basically means every single request that comes in will be caught by this handler. And the handler will just print hello web. And let me modify this, say that. So when I run this server, I think I'm still using up that port. I'm just going to close this down. All right, so I've started up this HTTP server. And then I can just open this, 4000. And you can see that it works. So This is a little web server, also written in Go. And the cool thing about this, um, even though we're just importing the HTTP package and starting up a server with HTTP listen and serve, this, in the latest version of Go, will actually potentially get you HTTP 2.0. That is the latest version of that protocol. So without me having to do anything extra or go out of my way, I can have an HTTP 2.0 server running. And this was the case as of like a year or two ago. So Go was pretty early with its HTTP 2 support. And this would have been pretty hard to do with, say, C++ if I were to do that. All right, so I'm actually not going to go further, but this is where I get to pitch a talk. This is actually based on a talk that Andrew Durand gave. This is one of my favorite talks about Go, and it kind of got me really interested and curious about Go. But this talk goes on with this chat-roulette program. It adds things like WebSockets. It makes this a real web app that uses WebSockets to communicate. Then it starts using Markov chains. So there's a bot that learns from the people that actually have the conversation. So when the first partner comes in and there's nobody to join them after 5 seconds, a bot will come in, start talking. It's going to learn from those conversations. There will be TCP and HTTP connections going on at the same time. It gets really crazy, but the changes that he makes to make all that work are really small and easy to understand. So this is the talk. And Andrew, he was on the Go team, and he's Google Sydney. So here's a link, and I think Yarek will share.
Markov chain will be on the final midterm.
Yep. So that is a very quick introduction to it. A Markov chain is it's an algorithm that lets you take some text, say English text, and kind of create sentences that sound like real sentences, even though they're all made up, and they potentially sound believable. So you should totally check out the demo, you'll see. So this is the second half, and this is where I want to talk about my journey, my personal journey as a software engineer. So I'll start at the beginning here. I got into programming pretty early in my teen, I think around 14 or so. But what got me excited was the ability to create video games. I mean, I had played them before that, but when I learned that you can actually write the code and make video games yourself exactly as you imagine them, that just made me very curious. And
all the gaming people are so
so I will be showing some of my projects that I worked on to give you an idea. But this is how it all started. Like, this is one of the earliest screenshots I could find. Some really old Visual C++ here. Some project that I was working on. Yep, you know it. So this was one of the early design diagrams. I was trying to come up with a good solution for having like an exception manager, log manager, and et cetera, et cetera. So this was not easy to do. This was one of the games that I worked on a while back. It was kind of supposed to be, it's a 2D side scroller, and you control these worms, and you could in real time just run around the map, and they could blow each other up. There was a console. Another small game that I worked on, it was the little crosshair, or the intersection of red lines you see, was supposed to be a penguin, but it never got to that point. I always started with the basics, and it just got left there. But it was supposed to be a penguin that climbs stairs of falling ice cubes, and you could have like a whole bunch of these cubes falling, and you could try to like find your way up. And you know, now that I look at it, it looks a little bit like Minecraft, and if I had just pitched in that direction, that could have been cool, but no, that didn't happen. So let me show a couple more projects. So unlike the previous examples, WormFX was actually one of the only projects that I back then really finished. So this is an example of a game that is really finished from beginning to end. So it's a game where you control the worm going through the cave. I'm sure you've seen games like this before as well. But what's cool is it has options, right? You can control the visual quality, the difficulty of the level, and etc. It actually has high scores. Like, once you have high scores in your game, if you're ever working on a game, you know you're done, because that is the last thing you'll ever add. So I can try to play a little bit just to give you an idea. And, all right, it's not too bad. Still easy. Skip that apple. Oh no, I missed it. All right, I give up. But actually, another cool thing here is when you're in the main menu and not playing, if you look in the background, the worm is actually doing its thing. So there's a little bit of an AI controlling it, and it's trying to do its best to like not hit the walls, get the apples, and yeah, it's kind of neat. So uh, I think just one point that I want to illustrate with this is that the experience you get from working on prototypes and projects, it's immense, and you'll learn a lot from trying different things. But the experience you get from actually finishing a single project, it is another thing that you should also try to have at least once because it teaches you so much as well. All right, and I'll show EXO. This is an old project of mine. So again, 2D. This was supposed to be a game that is somewhat reminiscent of Counter-Strike, except top-down view. So let me fire it up. All right. So you can choose a team, let's say red. And so I control this guy, and as I move around, what's interesting here is that there's this field of view, so I can only see what is directly visible in front of him. You can't really see through the walls. So let me add some dummy targets so I can shoot at them. Okay. So yeah, they're not really smart. They don't shoot back. Oh, except that guy. But still, there's the second gun that shoots like an invisible grenade, smoke grenade plus explosive grenade all at once. So yeah, this was something I worked on, and what was interesting about this is everything you could see, this was compatible and it could work over the network. So you could play this game from multiple computers from different countries, and I tried to take the best of the networking models of the Half-Life engine and the Quake. Like I took their best features and I tried to combine them, and it had some really interesting properties as a result. So it worked well, but this is where it was at. All right, so let's go on to the next one. And you might have already seen this, but that project, the EXO game, was written in C++, and that was kind of what I moved towards early on because it was fast for video games. This was important. It was cross-platform, and I cared about that even back then. And it compiled native binary, so you don't need any runtime to run it. So that was pretty cool. Then later on, when I was doing my master's degree, so I'll briefly mention this. When I was making a decision of do I go for master's or do I just stop at undergrad, I was considering going for game development. That was my absolute passion. I really wanted to do it, and I thought I wanted to do it professionally. But I wasn't completely sure, and had a pretty good opportunity to do masters. The topic was going to be in the computer graphics as well as user interfaces field. So it was pretty close to game development, and it was a good opportunity. And because I wasn't completely confident that games were for me, and also like the job market at the time wasn't great, I thought, okay, let me do the masters, and that'll kind of help me figure things out. So I'll show my master's final thesis project. So first, some context. If you've ever used any kind of 3D modeling software, so in this case, I'm going to show SketchUp make. So here's a very simple scene. And as any 3D modeling software, it will let you select objects and move them around. So here's like a picture. I can select it, and then I can move it around. So one of the tasks that you do pretty often is just move objects around. So if you want to put that somewhere, you can do that. And the tool that lets you move objects, at least in our software, it is very sophisticated. You can see there's a whole bunch of hints that show up. You can click on various endpoints, and depending on which one you click, it will do different things. So if I want to just quickly move that cube over onto that shelf, it's actually somewhat tricky. You have to be careful to pick the right point on the cube and click it. So the goal of my thesis project, as I'll show in a second, was to make it much easier to just quickly move objects around. This kind of tool here, it has a lot of precision, but it is not great for just explorative manipulation. So let me fire up Xcode again. There we go. So you can see it's a very similar scene. And what I can do here now is essentially click on an object and start moving it. And as I do that, the object essentially slides on the surface that is behind it. Because most objects are always on a surface, so this is a good natural assumption to make. So when I hit the wall, it just starts climbing the wall. It doesn't go through the wall. So that makes it super easy and quick to just move objects around if I want to do that. Say like put this cube over here, put another one over there, take the book, put it on the shelf. And when I do that, all the objects are going to be snapped precisely to the background geometry, and it's not going to be intersecting or floating in midair. So for really quick movement operations like this, it's actually really efficient. And also, like another feature of this is that if there's an object that has multiple valid positions in depth, we can actually use the scroll wheel to kind of snap it back into the background, or even more so in the background, or bring it forward like that. So when we did studies, this performed really well compared to the other methods for translating objects. Now, here's what is interesting. When I worked on this, this was also in C++. So you can see this is a really big C++ project. And let me get into the next part here. But it kind of, like during those 2 years when I was working on this, I kind of realized that the reason I wanted to get into video games, the reason I wanted to make games in the first place, is because I kind of wanted to help people. And indirectly, I thought that, you know, you could make a game that is like really sophisticated, has like some sort of deeper message behind it. And when a person plays it, they want to become like a better person at the end. I don't know. In the end, I thought there's actually a much more direct way to help, and that is to create tools that let you do the thing you want to do better. And that's the experience that I saw, that I got here. Another factor was that when I was working, this was with C++ here, I kind of grew frustrated with the experience that I had working on my project in this. So I was using, I think, Visual Studio at the time. This is Xcode, but I think back then it was even worse. But to this day, C++ has really a hard time with refactoring. So the tools are not that sophisticated because the language is so hard. So it is really hard to create these tools. I think C#, Java, etc., they have a much better refactoring story. But the experience of like trying to rename a class or like change the header file or something like that after every single modification was very frustrating. And what kind of upset me is that I would have to make the same change twice. Like I would have to change the CPP file and then the header file. So I thought there's got to be a better way, and I was really extremely motivated to do something about this. So there was a talk that I had seen given by Brett Victor, and this is a really incredible talk. I recommend you watch the first 5 minutes, and if you don't like it, stop there, but he'll give some really, really impressive demos of various UI interfaces that he created. So this guy has a very impressive background. He worked at Apple, and he worked on various prototypes there that inspired some of the things that they've been doing. And then the talk goes on about a different topic, but he kind of paints this picture. Now, I'm not going to do justice to this talk, so I really recommend you watch this if you're interested at the end, but I'll try to give you the idea behind it. So he talks about a different way of kind of living your life, and that is to kind of have a guiding principle that really inspires the work that you do. So he shares he describes that there are two kind of traditional paths that many people take, and they're the paths of the craftsman. So this is somebody that practices using their tools, and they're really good at using that tool or their craft, and that becomes their day job. Another path is the knowledge worker, basically, and that is kind of like if you're doing research, either in academia or you're maybe creating a startup and innovating on some product, you're kind of solving problems that nobody has solved before. And then he goes on to say there's this third path that is rarely talked about, but it's very interesting as well. So there's this path that some people have undertaken, which is kind of, it is driven by their guiding principle. So I will give an example of where you task for. So who here knows copy, paste, and cut, these traditional text operations? Everybody. So back in, I don't know, 10, 20, 25 years ago, that wasn't the case. They didn't exist. And at the time, if you wanted to edit some text what you'd have to do is you would open up the text editor and you would enter a different mode depending on what you're doing. So if you're trying to add text, you would be in the adding text mode. If you're trying to delete text, you would have to switch to a different mode, and then you can delete. If you want to move your cursor over, you would have to enter the mode for moving the caret. And it was really hard. Like, people could not edit text. You'd have to be like a professional that spends maybe months or years practicing the software before you could do data entry. And this person, where he Tesla, he basically thought this is completely wrong. He saw that this could be so much better, and he ended up inventing what we now know as the kind of what you see, what you get, the text editing, where you can just move the cursor with the mouse, copy, cut, and so on. So this person, let me also show you his website, nomodes.com. So his URL is literally nomodes.com. He was so against having modes that was his almost identity. So he ended up working on a lot of projects. He was a researcher and worked as a consultant and so on, but they were all to kind of realize or kind of fix the world as he saw it, and that is to make it so that there are no modes because they were not good. And in a way, he shaped the world in a significant way because now we're using much better ways of editing text. But yeah, this is an example. And for me, this talk really resonated because I felt like there were things that I really felt passionate about, I just wanted to do. And this was kind of like a way of describing how I felt. So given my experience of being frustrated working on the C++ projects during the course of my master's, after I finished my master's, I said, okay, I'm going to spend a year and just work on trying to fix this situation and try to do something about it. So I started working on this project, and I will give you a quick demo behind it, but it was an experimental project. So, okay, I'll annotate this demo. So everything that you see in here, it is basically widgets placed on a canvas. And each widget has, can be a button or a switch. And this canvas can be moved around. You could zoom in or you could zoom out on it. And there are different types of widgets. And they basically have some rules as to how they look and how they can be interacted with. But the idea is the widgets can be used by humans as well as other widgets. So here you have a simple text box widget, and on the other side you have this go-thumped widget. So now you can connect these two together, and whenever you edit the text in the text box, that go-thumped will always run and will format this, in this case, go code. So you can see as you make changes, that gets updated right away. Here was a button. With one button press, it would create a gist, it would clone it to my workspace, put it in the right place, open it, and make it so that I could paste a snippet of code and then commit it and then be able to use it in the future. I'll actually use this right away. But what was great is that I didn't have to do 10 steps manually as I did very often. Instead, it was just one. It was condensed to a button press. So here I'm solving the task of building a climb. So the goal of this program is to print its own output and have it be exactly the same as the source code. So as I start working on it, I want to see, am I getting closer or not? So I'll attach this go run widget. So now it's running the program that I'm writing, and I'm seeing what is the current output. So I want to see what is the difference between the current source code and the output of the program. So that way I'll know if I'm getting closer. So I connect this diff widget, and now as I make progress, that diff becomes smaller, and I can see it right here. Now I'm going to cheat a little bit by using the packet or the function that I wrote previously that finds the path to the file of the current file, and that'll make writing the rest of this much easier. So there it is. I found this is the function. I can use it. This was just a quick prototype, so I imported that package, and then it gives me the path of the file. So now that I have that, I can just use ioUtil to read the file and print it to the standard output. So when I do that, I get a nearly perfect line, so it's off by the new line. There's one extra there, so I'll just get rid of it, and there we go. The task is done. So in this case, I was demonstrating that some of the widgets that I created previously, they can be reused as part of other widgets, so I wouldn't have to kind of do that work twice. Here I was trying to experiment with concepts as objects instead of like just text. So there's that. Here's another example. There's a little program here. and here's its output. But it's using a library, and suppose I want to modify the library so that it changes the text that comes after those two slashes. So the way I'll work on this is, here's the source code of this package, of the library that I'm using. I have it side by side, so I'll connect the program to the library. So now, whenever I change the library, it will rerun the program, and I can see what happens. So I can then zoom out, find that piece of code that I want to work on inside of the library. There it is. I can find it by zooming out. There it is. So I'll just bring that over so that they're right next to each other. So now what I can see is, as I'm modifying the library, I can indirectly see how that influences the program, the original program that I wrote. So those changes, you can instantly sort of see the effects of those actions that you're taking. Now, if you're working on refactoring, you don't want the output to change, you can use this diff widget. And with it, you can see that, okay, the output hasn't changed, or it has in a certain way. You can also operate with external tools. So if you modify that file with Sublime Text in this case, and you save it, whenever you do that, Conception, this project would pick up that change, and you can see it show up as well. So the message behind this was that the project was kind of a playground of various widgets and tools, and they kind of let you visualize certain things that you're working on, and they let you solve the problems that you might have in your head. So like if you're trying to use your head to solve a particular problem, you can just try to use a widget for that, and you can create new widgets that address your the things that you might want to have, or something like that. So it was kind of like, how you use this is really up to you, but it was a very interesting project to work on. So I'll let that wrap up. So what happened next was pretty exciting. So there was a conference, the Live Programming Contest. Sorry, it was a Live 2013 workshop, and they had this programming contest for live demos, and I ended up submitting it and winning first place. So this was cool. I mean, the work that I'd done was recognized, and so this was a contest for anything that had live interactions, meaning as you change one thing, you can see the effect elsewhere right away. But what was also really cool is that this got me to visit San Francisco. So I wanted to go there. This is the Silicon Valley. I knew that the tech is really awesome there, and all the companies, the startups, the big ones, the small ones, they're all there. And this was kind of like a dream come true. I got to visit it, and you know, the weather there, the sunshine, it's really fantastic. Seeing that Golden Gate Bridge. Yeah. And somewhat later, it also helped me land my first job in San Francisco. So this was also there. So that's basically how I got my foot through the door. I got a chance to live and work there. So once you get into the first startup in the Silicon Valley, it's much easier to kind of get the next job offer, because they're really looking for people there. So if you're already hired by a company, you've sort of been vetted. So then, you know, it's a lot easier. Like, they're basically fighting for you, and they're trying to get you to join their startup and so on. But let me share some of my kind of insights about what the startup life was like and some of the takeaways from there. But I'd say that one of the most beneficial things about being there is that San Francisco, I guess, it has some really, really good talented people there. And one of the best ways you can learn is to just put yourself in a room where you're the least smart person, right? Like, that's how you learn, because you're exposed to other people that are doing better work. As long as you're motivated, it is a really quick way to get better. Another aspect is that when you're an engineer, so you have to consider the fact that the value that you bring into the company, it sort of varies over time. So at first, when you're just hired, it doesn't matter if you're a junior programmer or even if you're senior. At first, the company is sort of investing into you because you're very new there. You have just joined. You don't really know what you're doing. So you're not bringing a lot of value at first. But over time, as you get more comfortable and you get better and you know what they're doing, the work that you end up doing in the future that ends up being worth so much because the companies can then grow. They can become much bigger. They can either go public or get sold or whatever. So the engineer work that you do enables all of that, and that earns them a lot of money. So that's why they're very happy to hire people, because in the end it gives them the value. But you do have to realize that like it is a bit of a shift over time. Um, so the feeling of having your first program go into production, this was something you probably won't forget when it happens to you, or if it happens. So if you're working on some code and you're just working on an assignment or your personal project, you can feel pretty confident about it. Like you know your stuff, you know it's gonna do the right thing. But when you take a program that you've written and you put it in production, so now the company depends on it. There's a lot of users that are visiting and they're affected by whether or not this project works, and the company will actually lose money if your program stops working. And maybe it has to run 24/7 if it's a website. So now you have to like be very sure that it works. So it's really sort of nerve-wracking at first, but over time, as you get more experience and you kind of get used to it, you feel that if you do your job well, then most of the time things do work. And if something does go wrong, it's relatively easy to identify the problem and fix it and have things continue to work from there. So I'll talk about diagrams and whiteboards. That's something that happens very often. I've had multiple situations where people basically, when they want to talk about how to solve a problem at a higher level, people always flock to some sort of whiteboard and start drawing things, because that is how you discuss things, and when it's not the low-level implementation detail. So I remember actually at my second startup, there was a week where we wanted to kind of re-architecture our product, and we wanted to kind of export different things. So there's a week where we literally did not write any code. Like nobody on the engineering team wrote codes. We all got together. We had a week of just planning, and designing, and just spending in front of whiteboards and really thinking about how the product can work. So, and I think that can be really fun, because that is where you're making the really important decisions. That's when you're architecting the projects, and then you have to implement it, which can also be fun, but it's not as significant, not as impactful. Yeah.
Are you saying that UML diagrams are important?
Well, they do come up very often. Yes, super important. That's
right,
more important than
the
code. So
you better study hard, right?
another point is that hiring in general, it's really hard, especially for the companies Silicon Valley, because how do you know if the person that you want to hire is good or not? It's really hard to find candidates. And actually, like the whole process, I'd say like it is really broken, but at the same time, it's really hard to do anything about it and make it better. But I'll share a story about that in the future as well. But something that is relatively well known is that the statistic is that only like 10% of startups end up being successful. Like all the 90% of the others, they just go away. They don't really become profitable. They don't have this successful outcome. And what's really interesting, that like having experienced some of that firsthand, I've seen that luck does play a huge role. So that outcome, basically, as you're working on the company, you're making the product better, and so on. You have certain ability to influence things, but at the end, there's so many bigger forces out there, and you could see that like this was the story of my first startup. It did not have a great outcome, and the thing is, it was very close to having one, but then things just didn't quite come together. So it really is the case, and you never really know until the very end. But yeah, yep.
So, like, if any of the students in the class would ask you about their future career, should I choose like IBM, like Amazon, or should I go to like some startup like in Toronto based or California? Like, what would be your advice?
Yeah. So I would say that one of the big benefits of being at a startup is that you get to experience many different things. Like you see everything. You get to wear a lot of hats. Whereas at a bigger company, you're often, working on a very established project, and you have a specific role in it. So if you want to kind of experience everything and get a chance to like, do the front end, do the back end, and to like do all kinds of parts of a project, then a startup will expose you to more of that. On the other hand, if you know that you want to research a specific field and you don't want to be like bothered by the websites shutting down in the middle of the night, or you want to like focus on something that's a little bit higher level, then bigger companies will offer that. But it really depends on what you want to do, and having the experience here and there can be very helpful as well. So some of the other perks of being at startups, probably seen this from the show Silicon Valley, but there's free food, there's like all kinds of perks. They'll pay for your cell phone, they'll like pay for your Ubers, whatever you want. They kind of want you to have a great life, so like you don't have to worry about anything and you can continue to focus on work, so you're not distracted. So that's kind of the other side to it, is that you do work hard because the goal is to like make the company successful in a short amount of time before it runs out of money that has raised. San Francisco, where I lived, it has really awesome weather. There's so many events that are happening in the city. It's a very exciting place to be. There are meetups, like there are all kinds of meetups for any kind of topic. Has really great foods. But on the other side, it has really expensive rent, like even more expensive than Toronto, and there's the homelessness problem. So there's that. So yeah, back to the point of hiring is hard. The thing to realize that the startups tend to have some capital that they've raised, and once they've done that, they're kind of bottlenecked on people and the ability to create their vision and iterate on their idea. So here's a little real life story about a start. So this kind of start, if you've ever been on GitHub, you've seen that you can start projects, kind of like saying, I like this, or bookmarking it. And so what happened here is that when that conception project ended up winning the first prize at that contest, it got published, and it got submitted to Hacker News, this popular website for like tech news and so on. Got uploaded, and it was it was at the top here. So this got a lot of visibility to the project. Now, what ended up happening next is that this guy right here, Artsy, he started it, okay? And like I said, hiring is so broken that I can't believe this is what happened, but Joanne, so she was actually working at Trig at the time as a recruiter. So one of the ways she was looking for more candidates was to go through all the projects that Artsy from the previous slides had started, because Artsy was the CTO, so he was very knowledgeable in the tech field, and whenever he started a project, it's probably because it was pretty cool. So then Joanne ended up seeing that he started my project, so she reached out to me. We started the conversation, and that's how I ended up being at Trigit, that first startup in San Francisco. So it was all thanks to that one start. And another story about hiring, it's about a very talented engineer that I know. And so this person, he ended up getting a job at Evernote when he was doing his first sort of job search. He went for a round of interviews. He had a successful run, so he had a lot of offers, and he was kind of choosing where he wanted to go. He went to Evernote. He was there for about a year, and like I said, this person, I know him personally. He is really, really good. Like, he's one of the most talented engineers I know. He actually interviewed at one of their startups, and I've seen, like, he went through the interview process. He just nailed it. He was so good that we were trying to give him an offer. But then later on, Evernote, they were downsizing some teams, and he ended up having to go somewhere else. So then he started looking for a job again, and this time it went completely bad. So it's incredible, but the round of interviews that he had the next time was basically abysmal. Like, he went to one of the companies that was actually fighting for him before Evernote. They really, really wanted him to join or consider. Now they were giving him the cold shoulder. They're not interested anymore. And the other companies where he applied, he had no luck there either. So that was very kind of, not a good outcome at first. But then he waited maybe 2 or 3 weeks. He went for yet another round of interviews at a couple of companies, and this time it went much better. So then he got offers from the likes of Microsoft and Google, and now he's working at Google. So like I said, this kind of shows that hiring can be very unpredictable, and what ends up happening is that when you're doing your part, if you're at an interview, no matter how well you do, like if you do the best you can and you just really impress them, that is really only the 50% of the outcome. The other 50%, that's kind of determined by the other factors, the company, what they're thinking, what they're going through, and their internal processes and so on. So it's kind of like luck. So you can't really guarantee anything. That's why you have to try multiple times. All right. So I'll talk about open source. I'm a big fan of open source, and I've really enjoyed working with it. And one of the main reasons why I like open source in general is that it's free for everyone to contribute. So on the other hand, like if you're working on some Apple product, like you can't be at Apple and Google at once. So if there's a problem in your MacBook, you can't like both fix that, but also something in a proprietary Google software. So I'm very prolific in it. This is my GitHub profile, so you can see I've got a bunch of open source repositories. I've contributed a lot. I've contributed to a lot of other projects, some that I've used myself, etc. Here's somebody built this project. It's called like showmyprs.com or something. It takes your GitHub profile. And by the way, how many of you know or have heard of GitHub? Okay, so you heard of it, right? So you can just put your repositories there, and these are all the pull requests that I've made. So you can see this is a very lengthy list over the years. So one of the packages contributed to a lot was this Google Go GitHub. It's their Go client for the GitHub API, and Google created it, funnily enough. But yeah, it was a great time working on that project because it has some great maintainers. And actually, over time, I gained their trust, and they ended up promoting me to be one of the maintainers, so I can help out and accept other people's contributions, help review them, and so on. But yeah, you can see this list goes on and on. And I can try to talk about like why would anyone want to contribute to open source? Like what's in it for you or others? So I'd say like the number one reason to it is because you want or need it yourself. So if you're working and using some project that is open source, some library, and you code and has a bug in it, right? So suppose you fix it because that bug is preventing you from doing your work. Then you have the choice, like do you just stash it away? Do you have this like little hack in your project? Or do you try to like upstream send this patch to the original project so that everybody else, including you, can now benefit? I think the latter is often the better thing to do in the long run, and you benefit, others benefit, and you don't have to like maintain that patch yourself. So that's one of the good reasons. But also, open source gives you a chance to really improve your skills. Like working with other people, especially people that are really good, you can see how they're approaching different problems, and you can learn from them. So it gets you a chance to collaborate before you would be doing that at a company, for example. You can also build a reputation. So once you've got some sort of a portfolio, it becomes a much easier job finding a job because people, they can just look at the work you've already done, and that's already going to demonstrate what you're capable of. Whereas if you have no open source, I mean, it's a factor. It makes it a little bit easier. But yeah, and there are different ways of contributing. You can not necessarily just write code or send pull requests. You can also help triage issues or reproduce a problem. Like if somebody says this happened, can you actually reproduce it? And of course, writing code too. So I actually built, this is on my personal website. This was a little thing that I enjoy doing. This is a very detailed sort of activity or profile, or like, yeah, activity feeds. So all the open source events that have happened, like whenever I comment on issues or push new commits or branches and so on, like they all show up here. So you can see that in a lot of detail. So yeah. And another aspect of open source is that whenever you're starting out, you're always going to start small. Like you're not gonna make the first contribution that is like, it's gonna fix the world and make everything better. No, the first change will only touch something small. So here's my first commit to the Go project itself. You can see this is literally a single line, just a little improvement. I saw there's this opportunity. It was using a byte slice, but there was a variable that I could use instead. So this was just to kind of test the waters, and you do this so that you kind of get a feel for what's this process like? Like, are the maintainers of the project receptive to your changes? Because maybe they'll never even look at it. But by the time I sent my fifth commit, you can see that this was a much more significant change. So this fixed two issues. You can see the commit message that describes the motivation and the change in detail, it's very lengthy. And the actual change itself, this was very sophisticated, hard to come up, and I spent a lot of time, and also it required a lot of intimate knowledge of this particular code base. But it was able to, in the end, fix those two issues that were bothering me, and I wanted to see them fixed. So this was a much bigger contribution, but I didn't get there on the first commit. So that's the point here is that it's okay to start small. That's always how it's done, but you can grow to bigger contributions from there. What was really cool for me is that Go, it feels like it has a community, at least for me. And when I was using C++, it was kind of like a much bigger language. It was more mature, and there wasn't as much there was much more diversity in that field. But Go feels very unified. So there are conferences, there are meetups, talks, and so on. So I had some really kind of nice, fun milestones where I got to meet people from the core Go team. So this was when I met Andrew Duran for the first time. He's actually the person that gave that original talk. So yeah, he's from Sydney, but he was visiting SF. And that's David Crosshair. He worked on some image manipulation libraries. He also worked on the mobile story of Go. So these are really impressive people, and it's great to kind of get a chance to meet them. And so here in this picture, the language Go was created by Rob Pike, Ken Thompson, and Robert Griesmer. And this is Rob Pike right here. And that's his wife, Renee French. She actually created the gopher. So that the mascot, it's her design. She drew it and everything. And that's Francesco Employ. He was at Google on the developer relations team. I think he's working at a startup now, but he contributes a lot to the Go community as well. So it's great to just get a chance to meet them and talk to them. So what I'm doing now, and this was the case for most of the last year, 2017, is basically I'm working on full-time on open source. So I left my previous companies in San Francisco, and I came back to Toronto. I've been here since then. And I've been working on full-time on open source. That includes some personal projects, as well as contributing to the likes of Go and Go4JS. So, Yark, how am I doing on time? Okay, so let's see. I'll have a little quick bonus here, maybe. So this is about browsers and Go. Because I really liked Go, I wanted to use it. At the same time, it was hard to ignore the browsers. There's so much that happens in our browsers. They're very capable.
You can do 5 minutes for bonus and 5 minutes for questions.
Sounds good. Yep, I'll make this short. So the story with Go and its cross-compilation support is that it already supports a whole bunch of different platforms, right? Like it runs on Mac OS, Linux, Windows. It also supports these more exotic OSs like Linux on IBM Z systems. It also supports mobile. So iOS and Android, you can officially compile your Go projects and have them run on those mobile devices. So if you look at the entire list, it is very lengthy, right? And I was thinking, like, what happens if you just try to add one more? Like, the Gopher wants to jump into the browser and be a part of it, right? So, like, what if you could do that? Write your Go code, have that run in the browser. Now, luckily, there's a project that enables exactly that. So it's called Go4JS. It's created by Richard Musil, and it is a compiler that takes Go codes and compiles it to JavaScript, which then can run in browsers. And the timeline here is that in 2013, it was initially created, and then by the time it was 2015, it supported the entire Go language specification. There were no significant caveats, and the last 3 years, there are just minor enhancements. So this is the project on GitHub. You can see it has a lot of commits, a lot of files, and so on. But yeah, here's a little playground. So you can see that this is running in a browser, and because Go4JS itself is written in Go, it can then compile itself into JavaScript, and that can run inside the browser, and then that can compile more Go code and have that run in the browser. So it's kind of mind-bending, but it all works. And this kind of allows you to write some code and then have that run in the front end and do things like that. Right, so I will stop here. But yeah, if you want to see more about this, I actually gave a talk at .go that talks about Go inside the browser, which is not commonly done yet, but I think it's a pretty cool concept. And if you want, you can see that. But yeah, that's all I got for now. Thank you.
Thank you very much. I really enjoyed the talk, and it brings over memories from our grad school and all the discussions that we had. So we still have like a few minutes for questions. Like, yes, and it can be like technical questions, but also like personal questions, like your guys choosing your career, right? So
when you say you're working in open source currently,
Yep.
does that mean like you work from home?
Yep, I do now. Go ahead.
I'm a game developer. I gotta ask: is Go feasible for game development? Like, how fast is the language? Is it decent for desktop development? Does it have support for OpenGL?
I'm glad you asked. Actually, I have some extra demos. Maybe I can show to the people that are interested after. But I'd say it's definitely very viable. I personally really like. I'm biased, but I would say like it is great. I'm having a great time. I made a bunch of games with it. They're all small, but I haven't gotten to the point where the performance is bad enough. You know, like it's so far really a great experience. Yeah, and a lot of support for OpenGL, WebGL, you name it, even Vulkan, etc. Yeah.
Who pays you if you just work from home?
Yeah, good question. So open source, it is a tough world to be in, and this conversation is kind of starting in a lot of places. But like, it is happening mostly by people that are paid at their day job, and then they work on open source in their free time. Like they'll go home and then they'll work on it in their spare time or on the weekends and so on. And that's sort of what I did. That's how I did all the open source that I did back when I was in San Francisco. But because I was so passionate about it and I was really interested in keep doing this, what I ended up doing is kind of saving up money towards the goal of being able to sustain myself and do this a bit longer. So I kind of
we're talking about the startup salaries like 150K per year. Right?
yeah, US dollars. So they pay really well. So as long as you don't like spend it all on some like 3-bedroom or 2-bedroom apartment or a lot of food, I don't know. You can definitely save up. So that's how I was able to afford it last year. This year I'm starting to think about additional source of income and how to change things up. But yeah, it's a tough problem to solve. Like how to do this sustainably and continuously.
And we had a discussion when we were driving together that now like Dimitri considers like for example like applying for Google positions, right? But that's something like probably I'm not sure if you agree. Like you cannot just like finish undergrad, apply for Google, and hope for the best, right? And that's probably like also the advice that you would give based on what I've seen that like you build your portfolio over the time, and eventually the opportunities will come, right? But in order to that, like you actually have to work hard, right? Like go for some competitions, like participate in some events, like have your like GitHub portfolio. That's something that you can currently work on, right? Like, would you agree that?
Yeah, all these things they definitely help. And if you're ready to start looking for a job, you can start doing that, and you can start doing this at the same time. So like all these things will help you, and like it doesn't go to waste.
I have like 2 questions.
Yeah.
First, how did you build your knowledge throughout the years, and 2, do you see yourself beginning a startup?
Yeah, great questions. So how did I build like my knowledge over the years? So it's mostly through working on all these things. So there were either projects I wanted to accomplish or problems I wanted to resolve. So the way that I personally tackle most problems is just kind of head on. I look at what the situation is. I try to understand the relevant context and learn about the relevant backgrounds and just kind of like ask questions, maybe to the people that are more familiar with that specific field. So just fill the missing gaps and just try to solve it. And as you try, you'll have either some success or you will learn where things are not working out, and you can kind of continue to iterate in that process. So it's mostly just through trying things and just making progress. And the second question?
Do you see yourself just like building a
Startup. So I've definitely considered it and I've thought about it, but being like I've been the second startup when I started, it was like 6 or 7 people. I was in there pretty early on. It grew to about like 18 or 20 people in the 1.5 years that I was there towards the end. And I could see like from the beginning when it was really small, we were all just in one small office. I could see the work you have to do to actually start a startup. Like to be the CEO, you have to do so much, and most of that work, it's not engineering. Like you're doing everything except working on code. You're talking to investors, you're trying to raise capital, you're trying to recruit people, you're trying to do like marketing, you're doing everything. Like if the toilet breaks, you have to fix it because you don't want to distract other people. So like you do everything to support the company and try to increase its chances of success. And I found that like personally, I'm not into business, like that's not my strength. And on the other hand, I prefer working with software and development. So I'd rather spend time on that. So that's why I don't quite foresee that. But maybe we'll see. Like
And
it can
actually,
happen.
that happened. I also had a discussion like a very interesting person. He finished PhD. They actually created startups in Vancouver, but he said it was like a crazy life, right? Like basically 8 to 12, like every day, like weekends, no personal life, like no family, right? But somehow he was like just forget about it. He found a job like in Google, like 9 to 5. Like he says, like I don't care. Like at 5 I leave. Like I have good life. Like I enjoy it. So like that's something which I
Yeah.
also advise you to do. That in your like future career, you have to kind of keep the balance between your personal life and also your work. Because you may have a lot of money, but if you don't have time to spend those money,
It's a very,
what's the
very good point.
right?
Yep. And startups will vary. Some will have more reasonable balances between life and work, but many of them will be very unreasonable just because they need to have you working there so much in order to have a chance of being successful. Yep.
Do you tunnel vision like really hard when you're coding? And like if you do, and it's detrimental, how do you get out of that mindset?
I'd say that not too much, like not to the degree where it's a problem. I try to like kind of reevaluate whatever I'm doing. Like if I set out to solve a problem and I expected like this would take a couple hours, now it's taking a bit longer, like it takes me the whole day, well maybe that's fine. But if I see that it's taking like a week or like it's not moving as fast as I can and this is not a very important problem, then I would just not work on that anymore and shift to like a more important priority. So just keep in mind, like keep your higher goals in mind and just have that influence what you're doing. But,
Last question.
yeah.
I read that in order to become a better programmer, it helps you do projects that you're passionate about to learn more. Is there any other advice you could give to people that want to get better and improve?
Yeah, that is very accurate advice. I'd say like having the passion just makes it's just so much easier then to like channel your energy and improve as a result. Um, I don't know. It's tough. Like if you're really not that interested, it is much harder. You can still do it, but I'd say like it's probably easier to find something to be interested in and have that drive you. Like and maybe sometimes like you have to start working on the thing you're doing before you get interested, and you become interested afterwards. That happens. So you have to give it a chance.
And I have last question. So my personal view is that like to be successful also in the job market, you have to somehow distinguish yourself from other candidates, right? So for example, there's like millions of like thousands of Java developers, right? In your case, like you learn Go programming language. That's something which usually you don't have like in undergrad education. And that's why I always encourage students to learn something like different, right? Everyone knows SQL, learn Spark for Graph databases, right? Learn Spark for distributed environment. Like learn programming languages like Go, where there's actually demand for that, but not that many people know it. In my opinion, that's actually kind of like when you're on the job market, you can actually like everyone knows like web programming, right? Like, what is your personal view about it?
Yeah, what you said is, I'd say, very true. So one of the reasons I got that first job at Trigit was because I knew both Go and C++, and they had a lot of C++ and Ruby and other languages. They had some early success with Go, and they wanted to like transition. Like they had this bidder that only one person could work on because it was on their machine and it was too hard for anyone else to contribute. So then they tried to rewrite that in Go, and given that the experience in both, that's a very big, strong contributing factor. So having like some sort of niche, like a set of skills where they're at intersection, that definitely helps out a lot. So you can be good at one or two things. Yeah, very, very true.
All right. So thank you very much so much again for coming. And
Thanks.
for coming for the talk. Hope you enjoyed it.
But yeah, if anyone's interested in a quick demo, and if you have some extra minutes, I can chill here.
Questions to Dimitri, you can always like contact him from
Yeah.
email, right? Like if you have any questions, like go ahead.
Yeah, if you want to ask me more questions, I'm happy if you email me. Just let me know.
And follow your dreams.
Yes, do that.
I really want to see a demo, but I'm already late for a meeting.
All right, let's do this really quick. So I actually have a bunch of them on my website.
Oh, okay. Cool.
So if you go to projects, I'd say, so actually I have to open this in Safari.
Can you make these, Yara? Yes. Would it be possible for you to make
Yeah, he's going to share the
available
slides.
on the course website?
Yeah, he's going to do that.
Like we can send it to Slack.
So here's a little demo. This is a program I wrote in Go, and this will work in the browser, and it's also going to work on Mac OS, Linux, and Windows without me changing the code at all. So this is like a little 3D hovercraft, and you can race around, and like it bounces off the walls in an
I'm
interesting
impressed that
way.
there's already Vulkan libraries for it. That's
There
really
are,
cool.
yeah. There's
So this is
interesting people.
WebGL?
This is WebGL using, yeah, 1.0, and the library that I'm using, it's kind of like cross-platform. So look, I'll have the same code. Go cd cover with an E. So this is going to be the same Go package, and I can just go run it. Now it's going to be a native application running on Mac OS. And I didn't change that code, and now it's going to be using OpenGL 2.1, I think.
That's really cool.
Yeah. So you can change things here, and then the web version will update. Then I have this other game. I think it's here. CD. So let me show this in the browser as well. So this is that EXO game that I talked about before, but now it's rewritten in Go. The graphics are not there yet, but it's working in the browser and it's multiplayer. And this is the version that, like, if I'm gonna make progress on it, this is where I'll continue to do that. Oops, I need to do this in where's Safari? Yeah, I need to do this here. I have WebGL disabled in Chrome right now. That's why. So you can do this, and then if I just open up a terminal, go run. So I'm gonna tell it to connect to that same web server as a client with a view. And if I do that, here we go. So this should work. So as I move in this window, you can see that, yeah, it shows up there, and then vice versa.
That's awesome.
And I'm working on adding guns so you can shoot each other and stuff like that. But yeah, this is Go in the browser, Go on the front end. Go natively on Mac OS, and like these kind of games that I've done so far, like no problems at all. Unless like if you're building something AAA,
Yeah.
where it's like really advanced graphics, you'll have to be like kind of paving the path there. But for anything like even way more complicated than this, you'll have no problems. Like this is easily 60 FPS. Yeah, if you have like any more questions, you want to try this out or get into it, just let me know. Like I'm happy to share some of the like libraries or things to get started with this.
That's
or
really cool.
some of these examples.
Thank you so much
Yeah,
for coming in.
no problem. Glad you liked it.
I got to choose your demos later.
Cool. Well,
Have a
enjoy.
great day.
You too. Take care.
Okay, cool. All right, I'll see you around the audio.
All right, I'm just gonna stop the recording.